day. But before we start, you need a quick change. Now that we are all set, Wonder Warriors, let's begin! I have here two different materials placed on top of a flat surface. A food tray with half cup of water and two pieces of 8 by 16 centimeter foam. To start, let's label the foam. Angel, kindly label this form as A, and Vince, label the other one as B. Angel, kindly soak half of the length of foam A into the water. Next, place it on a flat surface at least 2 centimeters away from foam B. Then, position the soaked part of foam A in the middle part of the setup. This time, kindly hold foam A and hold foam B. At a count of 3, slowly push 4 centimeters inward each outer ends of the foams until they overlap. Ready? 3, 2, 1. Observe what happens. On a piece of paper, draw the final setup and answer the following questions. Question 1. Which foam curves above the other? Question 2. How does the water in the wet foam affect its density? Question 3. If the foams were pieces of the Earth's crust, which one is the continental crust? Question 4. Which foam is the oceanic crust? And finally, in the activity, what made wet foam move under the dry foam? To help you answer these questions, let's replay the experiment. This experiment demonstrates the processes that occur along a convergent boundary between an oceanic and a continental plate.
I have observed that when we slowly pushed 4 centimeters inward, each outer ends of the foams, foam B curves above foam A.
Good observation, Vince. Take note, the presence of water in foam A affects its density.
Density? Wait, I know what density is. Density is a measure of mass per volume.
You are correct, Angel. To recall, the average density of an object equals its total mass divided by its total volume.
Teacher Melvin, does it mean that in the experiment, one foam is denser than the other?
That's a very good question. Based on the experiment, we can say that one foam is denser than the other. So which do you think is denser, A or B?
It's foam A.
That's correct. The presence of water in foam A makes it denser than foam B. Good job! And now, let's answer the 5 questions. Question 1. Which foam curves above the other?
Based on the experiment, foam B curves above foam A.
How does the water in the wet foam affect its density?
Water increases the density of the foam due to the increased mass.
Question 3. If the foams were pieces of the Earth's crust, which one is the continental crust?
It's the dry foam or foam B.
That's correct, Angel. Which foam is the oceanic crust?
It's the wet foam or foam A.
That's correct, Vince. Question 5. In the activity, what made the wet foam move under the dry foam?
Due to its greater density.
That's correct, Vince. There! I'm impressed of your quick thinking. Wonder Warriors, don't forget to write down important concepts on a piece of paper. Remember, by taking down notes, you can easily recall the concept of the experiment. And now, let's proceed to another experiment using these materials. A food tray half filled with water and 2 pieces of 8 by 16 inches foam. To start, let's label this foam as A and this one as B. Second, let's submerge the 2 foams into the food tray containing water. Third, arrange them at least 2 centimeters away from each other. Fourth, Slowly push 4 centimeters inward each outer end of the foams. Then, observe what happens. On a separate piece of paper, draw the final setup. In the activity, what have you noticed?
I have noticed that one foam move on the top of the other while they are converging.
Good observation. Angel, if in the process, the top foam suddenly flips up so that some water is pushed forwards and up, what do you see on the water surface? A wave or a ripple? Let's replay the experiment. If the foams were Earth's plates, what do they represent?
I think they represent the oceanic crust.
You are correct, Vince. If the foams were Earth's plates, they are oceanic crust, where one subducts under the other.
Subducts? What does it mean?
This experiment demonstrates the processes that occur along a convergent boundary between two oceanic crusts. When two oceanic plates collide, a subduction zone is generated, which means the older plate is forced under the younger one, and it leads to the formation of island arcs.
Island arcs? Sounds cool.
Yes, Angel! Island arcs are chains of volcanic islands. Examples include the Mariana Islands in the Western Pacific Ocean and the Aleutian Islands off the coast of Alaska. Aside from the collision of two plates, what are your other observations?
Teacher Melvin, I have observed in the experiment that water is pushed forwards and up.
And created ripples or waves.
Very good observation. Since the collision and subduction of plates is not a smooth process, large, powerful earthquakes are another phenomenon that result from this type of interaction. Earthquakes generated in a subduction zone can also give rise to tsunamis.
I learned the previous episode that a tsunami is a huge ocean wave caused by a sudden shift on the ocean floor, such as an undersea earthquake.
Yeah, that's right. I also learned that if the wave reaches land, it can cause incredible destruction.
Good job, Wonder Warriors! I am extremely impressed of your progress. Because of that, I will give you